Hi guys, it's me again. I just wanted to get on here and talk about um math and kind of a bit about the philosophy of math and why it's special to me personally. Um so yeah, in my graduate courses, we've been exploring a lot. We've explored Euclid and we've explored Lobachevsky. Um, and they're developers of two different types of geometry. Euclid is like high school geometry basically. And Lobachevsky is like, a little bit higher level. But the thing that sort of strikes me, and this is not just about Euclid or about geometry specifically, but all math, is just the fact that how certain it is, right? I talk about how things really aren't certain in life in on this channel a lot. And so, but like mathematical and geometric propositions follow directly from one another based on a set of definitions and then assumptions about the things you can do with those definitions and things you can make. So like for example with Euclid, we have a definition of what a circle is, of what a straight line is. Now, there's some ambiguity in those definitions for sure. Um, but then we have what are called postulates, which is essentially allows us to start drawing things, simple things like circles and lines, and being able to extend them and it's just it's just really beautiful because after those things, when you start getting into the propositions, what you start to see is that the propositions are built on top of one another in the sense that they they build off of each other. So like for example, the first proposition in Euclid is how to construct an equilateral triangle, and all you really need for that is two circles and then three straight lines. But then in the next proposition, you it's about how to make a line equal to a given line. And in that um proposition, when you are trying to make equal segments out of the lines that you have in that proposition, you use an equilateral triangle in order to cut it into equal parts, which you just learned how to make in the proposition before. And that happens with pretty much every other proposition, and they're arranged in such a way where you know the sets of propositions have like themes, right? Where a group of propositions will be about parallel lines and all of their properties, and then you get to parallelograms and all of their properties, right? But they're arranged together from the simplest portions of whatever it is you're talking about to the more complex things. And so that to me is just that's so beautiful. That's the concreteness of that is just I don't even know how to describe it. But I couldn't um say that for a lot of other math stuff, derivatives and the way they are beautiful in a geometric and algebraic sense, how we play around with infinitesimals, and I just it's such a change, you know. Real life is so uncertain, but math life really isn't. Now I know that it depends on the assumptions you make, right? Like that's what we were talking about in Lobachevsky, because in Euclid you can only have one parallel line, uh, which is parallel to another point, another line through one single given point. But with Lobachevsky, that's not the case because he has different assumptions. There's this thing called the parallel postulate, which really should be a proof, right? Where he says that basically, um, any any parallel lines falling on a third line will intersect them if the angles that they make are acute angles, which is really um just saying something about the interior angles, the angles on the inside of them, which he actually proves later, right? But that seems um like something you can't just assume, you have to prove that. And so, but Lobachevsky gets rid of that postulate, and now you can have infinitely many lines parallel to a given line, uh at various points or from a single point, which is very interesting. Um, but in either case, they still, you know, have a set of deductions which build or imply a set of deductions which build off of one another and allow you to do all these amazing things. And again, that's just so beautiful. So beautiful. And I know maybe a lot of my viewers probably aren't math guys, or maybe they are because you guys are because you're gamers, but I heavily encourage you to explore that side of math and to explore what it's really saying to you about the world and about the way we think about things. All right, bye.